Welcome to our tutorial on debugging reactive streams in Java. In this session, we will delve into the complexities of reactive programming, especially the debugging aspect. Reactive streams provide an asynchronous and non-blocking way to handle data streams, but with that comes the challenge of understanding what happens during execution. To begin with, let's quickly establish what reactive streams are. They're designed to manage asynchronous data flows with backpressure, allowing you to handle data streams in a more efficient and straightforward manner. Before we get into debugging, let's define the reactive streams API. The core interfaces are publisher, subscriber, subscription, and processor. They represent the producers and consumers of data. For our demonstration, we will use Project Reactor, a popular implementation of reactive streams. Let's set up our project. If you're using Maven, you'll need to add the Reactor core dependency to your pom.xml. Here's how you do it. Make sure to refresh your project so that the dependency is correctly downloaded. With that said, let's jump into some code. We will create a simple reactive stream that generates a sequence of numbers. This code creates a flux that emits numbers from 1 to 10. Nothing fancy yet. But what if we want to see what happens internally when we emit these values? This is where debugging comes in. You can use the doOnNext operator to insert side effects into your stream. Let's modify our example to include this operator. Now, when we run this code, we'll see output indicating the emitting values. This can help you trace the flow and identify where things may go awry. Let's put in a scenario where we deliberately introduce an error. Here, if the emitted value is 5, we throw an exception. Our subscribe method has a second parameter to handle the error. When you run this code, you will see the output from 1 to 4 followed by our error message. This is a great starting point for debugging. But what if the error occurs somewhere deeper in the stream? This is where the concept of logging can significantly help. We can log each stage of the stream using doNerror and doFinally. Let's add logging to our stream. With this code, besides catching and logging the error message when the error occurs, we also catch the final signal when the stream completes. This can give us insight into whether our stream was successfully completed or interrupted by an error. Now let's talk about backpressure. When dealing with potentially large datasets, backpressure management becomes a crucial aspect. Imagine a situation where your stream is generating data faster than you can consume. In this example, we simulate a slow subscriber by delaying the emission of each element. To visualize backpressure, you can use onBackPressure buffer to build up elements when the consumer is slower. This will buffer up to 100 elements if the subscriber cannot keep up. If the buffer is full, the stream will drop elements, potentially resulting in data loss, which is essential to monitor during debugging. Now let's look at debugging with tools. Project Reactor provides Reactor tools for enhancing debugging capabilities. To use it, let's first add this dependency to your pom.xml. Once you've added this dependency, you can enable debugging by calling hooks.onOperatorDebug. This will allow you to view the stack trace of errors thrown in your reactive streams. Now running this code not only triggers the runtime exception, but it will also provide a detailed stack trace, which can significantly ease the debugging process. Let's summarize the key debugging techniques we covered today. First, we used doOnNext and doNerror for logging and tracing the data flow. Second, we explored backpressure and how buffering could impact our stream. Lastly, we enhanced our debugging with the help of Reactor tools. Each technique helps in isolating problems better in your reactive programming journey. Remember, debugging reactive streams can sometimes be tricky due to their asynchronous nature. But by leveraging these techniques, you can improve your understanding and troubleshoot more effectively. And that wraps up our deep dive into debugging reactive streams. I encourage you to experiment with these techniques in your own projects. If you found this tutorial helpful, please give us a thumbs up, subscribe for more educational content, and leave your thoughts in the comments below.